we will discuss why we are regarding Slickline as a key for well intervention. And this will be followed and at the end by a Q&A session. Of course, this webinar is regarded as an introduction for the upcoming 5-day course of Slickline operation. Okay, let's start. What is the definition of the well intervention? Well intervention, as we know, it's any operation in which a tool is deployed into the well to do a specific application. I'm deploying this tool into the well to do the application, and the target of those applications to enhance the production from the well, as if you encountered any problem causing a production decline, such as a scale build up, increasing water cut, and so on. So the well intervention technique you will choose will help you in finding the source of the problem and also will help you in solving it. To find the source of the problem and to evaluate the situation and also to help in solving the problem of production decline. In addition to the production recovery, there is which is called well integrity. Well intervention, our topic today, will help in recovering or maintaining the well integrity. What is the well integrity? The well integrity is the regulation and the rules for safe and efficient productivity from the well. All those will be maintained and accomplished by monitoring and applying the remedial action required by the well integrity regulations that will be done by well intervention. Okay, to know more about well intervention, we need to know when we will apply the well intervention. As we know, there is a life phases as shown, starting from drilling the well and going through completion operation. What is the completion? The completion are the operation in between the drilling phase and the production phase to complete my well to be ready for production by installing the required accessories, making a perforation and unloading the well and so on. So after that, the well is put on production. During the production phase, we are monitoring the production rate carefully because any decline in the production rate, I must go with a solution or make an action. The action here will be the well intervention. So the well intervention may appear on the well life timeline in the after the production phase. Why? To solve the problem, to evaluate the well firstly, and if I encountered any problem, to solve this problem by the well intervention method I will choose, and then applying the remedial action required to recover the production. Also, the well intervention can appear on the completion phase. When we are dealing with the completion, some tools are deployed into the well to perforate and unload and stimulate the well during the completion. So the well intervention will appear mainly after a production and can be also applied in the completion phase. And by the way, if the problem can't be resolved by the well intervention technique, so we may introduce a workover. The workover here, we will bring a rig. This rig will pull the tubing and solve the problem, the integrity problem, or deepening the well by extended reach drilling or side tracking or whatever. So and then by then the workover is a heavier application than the well intervention. So to know why we are applying the well intervention, we must know the reasons of the well intervention. The first reason of the well intervention is the production decline. If you are monitoring your well and you have a production decline, so you will interact with it either by, this is the result, but we must find the reason behind the production decline, whatever it's a pressure build up, the scale build up, or a sand plugging malformation, increasing the water cut, and may the perforation are plugged. So there are many reasons can cause the production decline. So you will interact with the well intervention here by deploying a tool to evaluate or to know the reason of the production decline firstly, and then to solve that reason by removing the sand or the scale, reducing the water cut by means of water shutoff, and reperforation if we need to change the point of producing oil downhole. Also, well evaluation. During the well life phases, you must know what is the production rate, the pressure and temperature of the reservoir to design your upcoming operations. So you need those data by logging techniques and PLT, production logging tools, pressure and temperature surveys, and so on, to evaluate your well and your situation and to take the right decision for the upcoming operation. So another interaction and a reason for the well intervention, the artificial lift. What is the intersection between well intervention and the artificial lift? That we can buy some tools, as we will see, installing and retrieving gas lift valve and jet pumps. Those artificial lift techniques can be replaced and maintained by well intervention, especially Slickline, as we will see. As we said, the well integrity, all the regulation and the rules to maintain a safe production. So how I maintain the well integrity by those well intervention techniques? By installing plugs for Christmas tree repair. If you have a malfunction or a damage on your Christmas tree, so how to change the Christmas tree? You must install a plug inside the tubing to isolate the flow from the downhole and then change your Christmas tree. Also, any casing and tubing repairs required, so you will deal with the well intervention. We can also, as we said before, we have plugging perforations and the plugging formations and reducing permeability by a formation damage. So we need which is called the well stimulation. The well stimulation to enhance the productivity of those plugged formation by hydraulic fracturing and acid stimulation. So this all answering why we are making the well intervention and when we apply it. So to answer what are the most well intervention techniques, the common used well intervention techniques will be the family of wireline. The family of wireline, which have the wireline have members like Slickline, braided line, electrical line, and digital Slickline. What is the difference between them? As we will see now, the wireline is a cable or a wire introduced into the well. Okay, but there is another technique, famous technique, which is called coil tubing. The coil tubing beside the wire line make the most commonly used well intervention techniques. And also there is a heavier application which is called a snubbing. So for the wire line is simply a wire or a cable introduced to the well. So there are many differences between the wire line and coil tubing and the snubbing. First of all, the force introduced to the well. By the wire line, it's the most light technique of the well intervention, and the coil tubing will be heavier than the wire line, so introduced higher forces downhole, and the heaviest well intervention techniques will be the snubbing. Okay, what is the difference between those members or the types of the wire line? All of these are cables introduced to the well, but the difference in the cable itself or the wire itself. For the slick line, it's our topic today, and we will see it in detail. It will deal with the mechanical operation because it has, which is called the mechanical jarring. What is the mechanical jarring? We will see the jarring effect or the strike effect or the hammering effect. So any mechanical operation can be introduced by a slick line because it's a rigid slick line, thin slick line, metal line or stainless steel, carbon steel or stainless steel line introduced to the well. The elasticity of this slick line can allow the mechanical jarring or the mechanical operation. For the braided line, for the braided line, it's used for more tension than the slick line. The tension for the braided line can be applied higher than the slick line, so it can be used for more tension application like fishing and swabbing operations. Due to the braided line itself, the braided line it's like strands connected together. These strands are have more tension or more to apply more tension than slick line. For electric line, it's also strands, the same strands here, but have inner core with a conductor material which transmits electrical signals from a downhole to the surface and to receive the data also from the bottom hole or from the tool to the surface and to transmit the signals from the surface to downhole. So the interaction between the bottom hole and the surface, which is called the surface readout, the surface readout is maintained by the electric line, so I can transmit data and receive the data from the downhole. The digital slick line combines the mechanical jarring of the slick line and the electrical line or the data transfer by it's the same slick line here, but it's coated by a conductor material from the outside. So this can do the both of the mechanical jarring and the electrical signal transferring. For all those, for the wireline family, slick line, braided line, E-line, and digital slick line can be called a wireline. The wireline cable introduced to the well under its own gravity. So I can put some forces downhole by either jarring for slick line or the digital slick line by jarring effect. For the braided line and E-line, I can add more weights by stem bars also, but it's limited to the gravity of the PHA or the bottom hole assembly. But in the coil tubing, which is a pipe, pipe with ID. It's a hollow pipe with IDs, so I can introduce a bumping capability, which is not allowed here in the wire line. The bumping here, I can bump from the surface, so it will open more and more applications such as nitrogen lifting, stimulation by acidizing, hydraulic fracturing, and so on. And also the coil tubing, as we said, it's heavier well intervention technique than a wire line, so it can apply more and more forces downhole. For the heaviest application of the well intervention, which is snubbing, it resembles a small workover, so it can be the heaviest. It can be the heaviest well intervention technique and can make a recompletion by pulling the production tubing. Okay. For the common tubing accessories, the tubing accessories, especially with the Slickline will deal with. So the common tubing accessories from the surface to going to downhole is a subsurface safety valve. Subsurface safety valve is a downhole safety valve with a gate, closes in emergency situation. For the type of surface controlled subsurface safety valve, it's controlled by a hydraulic pressure from the surface, and when we're releasing the pressure, so the gate will close in emergency situation. The Slickline deal with this tubing accessories. The tubing accessories mean it's a part of the tubing. Pin and box connection, pin and box, and all connected together to make the production tubing. So one of those accessories is called the subsurface safety valve. The Slickline deal with the subsurface safety valve for installing and retrieving some types of subsurface safety valve, like wireline retrievable subsurface safety valve, and also troubleshooting the tubing retrievable subsurface safety valve for a lookout and exercising and so on. All this details, inshallah, will be discussed in the course in details. For a side bucket mandrel, the side bucket mandrel is the place where the gas lift valve is installed. So also the Slickline, which our topic today, the Slickline will deal with this gas lift valves by to change or to set, to pull the old gas lift valve or to set a new gas lift valve by a Slickline. Also, there is a SSD or a sliding side door or sliding sleeve door. SSD is the way of communication between inside of the tubing and the annulus. The communication between the annulus and the tubing are the tubing to the annulus communication is implemented by shifting the inner sleeve inside this SSD. So it's applicable by Slickline also. And also the packer. The packer is the isolating element between the tubing and the casing to force the flow go through the tubing to the surface. This packer also can be set by installing a downhole plug, as we will see on the next slide, to set this production packer. And finally, we have a nipple. What is the nipple? The nipple is the internal profile inside the tubing to accommodate the setting of lock mandrels, and the lock mandrels attached to it the plug or the subsurface safety wireline retrievable subsurface safety valve, and so on. So any device or any subsurface tool I want to hang inside the tubing, it will be hanged inside the nipple, because it has internal profile or a groove to receive such devices. Here we will talk about the main objective. Till now, we understood the well intervention techniques in general, and also we will specify our talking about the slickline. Slickline as the rigid slickline, as we said before. This thin slickline are introduced to the well by means of, as we will see, surface equipment and the rig up of the surface equipment. So this slickline will introduce to the well, and so to know what is the main objective of this slickline, there are three main categories of all slickline applications. The first category is access to downhole equipment. I want to access to downhole equipment. So as we said, gas lift valve change. Gas lift valve change on the which is installed in the side bucket manual. I can go down to the well and retrieve this valves and change these valves by slickline. Also, the wireline retrievable subsurface safety valves, the subsurface safety valves that can be changed by wireline. So this slickline operation can change the wireline retrievable subsurface safety valve. Also, the shifting SSDs, the shifting SSD open or close SSD to communicate or to allow the communication between the tubing and the annulus, and to set any subsurface tool into the nipple, so the slickline will be used. The second category for slickline applications, obtaining the data or collecting the data for reservoir management or designing water intervention process or to evaluate our well. So the pressure and temperature surveys in memory base, pressure and temperature surveys, we are deploying a tool which has sensors of pressure and temperatures. Those sensors are recording the data in a memory base. So when we retrieving the tool to the surface, we will unload the data and analyze it. For well integrity, as we said before, how I maintain the well integrity by ensuring that the tubing are clear, there is no leaks, there is no collapses, and so on, by tubing drifting, and also setting plugs. The setting plugs will be discussed in this session. But firstly, how can we deploy any tool into the well? So if we imagine here, this is the Christmas tree and our well. So if I open the Christmas tree valves now, I wanted to deploy a tool here, from here, down to the well. So if I open the Christmas tree valves now, what will happen? There is an internal pressure from the from the downhole will be out of the well. So I can't go down. I can't go down with my tools against that pressure now. So there is, which is called a PCE, which if we imagine here, it's lubricators or risers, as we said. This is steel pipes connected together, a hollow steel pipes connected together and connected above the Christmas tree. This risers is a part of which is called a PCE, which is called a pressure control equipment to contain the pressure. That pressure will be now inside that tubing. But for that open end, we will use a stuffing box, which is a rubber element. This rubber element will close the open end of the risers. And now if we have our Slickline, we have our Slickline now spooled on that reel. The Slickline comes to the field spooled on a reel to introduce the total length you required for your operation. So this Slickline now are ready to go down this PCE and inserting the Slickline here inside this rubber element or packing element, which is called the stuffing box. By inserting the Slickline now and connecting to it the tools which will do my application, which is called the PHA or the bottom hole assembly. The bottom hole assembly, it's connected. It's some tools we will see now, but these tools will can go now down to the well, because this pressure will go inside this PCE, and it's safe now for lowering the tool. By opening the Christmas tree valves, the tool can be lowered now inside the well and do my application. So it's safe now to do our application. Okay. To imagine the Slickline rig up, as we said, we have this PCE, the risers, and the POP all connected above the Christmas tree. So the PCE, the pressure control equipment, stuffing box, lubricators, and the POP are connected to above the Christmas tree. And if we see here that we have a reel or the drum, which is the Slickline is spooled around, and a power pack unit. This power pack unit gives the power required for the rotation of the drum and the move the drum in upward direction and the reverse direction. All the motion and the hydraulics required for the motion of the Slickline comes from the power pack. So it's a generator, simply a generator to generate hydraulic power to the pumps, and the pumps are raising the hydraulic pressure in the hoses connected to the drum to make the movement by internal motors and so on. So this Slickline here will go in that direction and change its direction by 90 degrees, and then go up to the stuffing box. On the sheave of the stuffing box here, the Slickline will meet our rubber. So the Slickline will inserted inside the rubber, and here we connect our PHA now. So the PHA will be inside that lubricator. What is the most commonly PHA? It's the it composed of rope socket, the rope socket, which is the connecting element between the Slickline. So this is the PHA inside the lubricator. So the Slickline will connect it to the PHA, the bottom hole assembly, by the rope socket, and underneath it stem bars to give the required weight for the PHA to go down to the well against the well pressure and friction and deviation and so on. The mechanical jar connected to the stem bars, the mechanical jar. The mechanical jar is a component essentially for a jarring effect. I can do whatever, the downward jar or the upward jar, the jarring or the striking or the hammering effect can be maintained by the mechanical jar. So to activate the downhole equipment, The knuckle joint, it's optional for the PHA flexibility, especially in high deviated wells, and underneath it will connect our tool. So this configuration is fixed in most of Slickline applications, but we are changing that tool, which is connected down to the mechanical jar. Okay, to summary, what is the main applications? We can go with which is called the gauge cutter, and as we will see on the next slide, the gauge cutter, which will make the tubing drifting, and we can open or close the SSD, shifting the SSD to open and close the SSD. We can install or retrieve the plugs, which is a very important application, can be implemented by Slickline. And also there is, we can call this drifting, tubing drifting by gauge cutter, shifting sleeve, setting and removing plugs, and also memory logging, memory PLT, or temperature and pressure surveys, and so on to collect the data. All that application can be routine jobs. There is non-routine jobs in case of the wire cut. If I have a wire cut with my PHA down to the well, I can fish the Slickline by using another PHA, but connected to a special tools. This is called a fishing operation, which is very, very important application in case of a wire cut. Okay, to see some Slickline tools here. We have which is called the gauge cutter. So to clarify this point, this tool will attach it to the bottom of the PHA and can be changed from application to application. Okay, so the first tool we have the gauge cutter. The gauge cutter, as we see, it have a cutting edge, sharp cutting edge, and inside it we can any scale or any paraffin or wax can be removed by this gauge cutter. As we see, the gauge cutter will go down to the well to remove any scale or any wax or and also the gauge cutter, if the tubing is clear, it's used for the drifting, which is meant to tag the accessory, the tubing accessory, to be sure that I can reach to that tubing accessories without any obstruction, which is called the drifting or tagging. The gauge cutter, and this, by the way, the commonly used PHA, as we said, rope socket, stem bar, mechanical jar, nickel joint, and so on. There's also which is called a switching tool. Commonly used for the drifting or passing any edge of the tube inside. If we have inside edge or which is called a restriction, can't be passed by gauge cutter. So the switching tool, due to this this cross section, can be passed from any edge or obstruction. Also, there is an LIB, which is called lead impression block. The LIB consists of a metal body but connected to lead from the bottom of the LIB. So this lead can give me a mark to any unknown object inside the well. This is the configuration of the LIP before running hole. And if we have any obstruction, especially in fishing operation. In fishing operation, you can all the applications of the Slickline, as we know, it's blindly application. So I can't predict perfectly what is inside the tubing or what if we have a wire cut. So I wanted to make sure what is the downhole here by running hole with this LIB. This LIB in this lead portion will give me a mark. This mark will appear where? Will appear here. It gives a mark of a clear or a rope socket, and a wire attached to it. So this is can be used in fishing operation. Also, to complete this process of fishing operation, we will run with a blind box. The blind box here will strike. That's as you see, dummy box can hammer by a mechanical jar above the rope socket to cut the wire, and go then by which is called the wireline grab. The wireline grab will have an internal tooth to catch the wire and to go back to the surface. Okay. Till now, we have the most common applications. Also, there is some application as the tubing cleaning by which is called the tubing broach. Tubing broach is has a cutting element on the outside diameter of this tool to make internal cleaning of the tubing. As we see here, any sludges, any accumulations can be removed by this cutting elements. There is some auxiliary tools not commonly used, and a magnetic fishing tool. The magnet here will recover any metal elements inside the tubing and so on. The tubing indicator not commonly used. I will pass it. The sand baler. Sand baling is by it's like a barrel. This barrel has a bottom check valve. So when we are going to this barrel, it will have a sample. So it's called a sand baler or a sample baler to give or to make a baling, retrieving the sand from the inside of the well, and the check valve here to prevent any deposition again of the inside sand. Okay, till now we have discussed the common fishing tools and common or the slickline, ordinary slickline tools. To emphasize about this information, we can review the Slickline PHA, the rope socket, as we said, the connecting element which connect the Slickline with the remaining PHA. The stem bar here, is for the weight, to adding the weight to the string, and the knuckle joint, which is give a flexibility, as we see here. Gives a flexibility of the PHA during run hole in high deviated angles, and the mechanical jar, which is the most important PHA component, giving the jarring effect either downward or upward. And by the way, there is an also upward jarring mechanisms by hydraulic jar, spring jar, and so on. This PHA are connecting to the tool especially used when I do any application. So when I drifting my pipe, so I will connect a gauge cutter to that PHA, the gauge cutter, okay? And there is also the LIB, which have a mark, as we said. The swaging tool and the blind box to strike against any downward component. The wireline grab, which catches the wire. And also there is a huge category of bowling tools. Due to time, we will not discuss it now, but it's very important tools, inshallah, discussed in the course. Okay, for the Slickline common jobs, as we said, the full gauging. So the full gauging, starting from the full gauging, drifting the pipe by what? By the gauge cutter. The gauge cutter is the tool attached to the PHA to do the application of full gauging or tubing drifting, to drift the inside of the tubing, to remove any scale or paraffin deposition, and also to reach to the downhole accessories, nipples, to tag the nipples, to tag bottom hole, and so on. For gas lift valve change, it's accommodated by the kickover tool. The tool which is used for the gas lift valve change is called a kickover tool. This kickover tool can be run attached to the PHA to change the gas lift valves in case of we have any reason to change our gas lift valves from the side bucket mandrels. Also, to set or retrieve any downhole tools, there is an important configuration that we will see on the next slide, which is the lock mandrel attached to the any tool I want to set downhole. So if I want to set a plug, it will be a plug attached to lock mandrel. If I want to set to wireline retrievable subsurface safety valve, so it will attach it to lock, attach it to my PHA. So any subsurface tool I want to set inside, especially inside the tubing, it will be attached to the lock mandrel. And this configuration from the lock and the subsurface tool will be set inside the tubing, where inside the nipple. The nipple is the accessory of the tubing accessories, accommodating the setting of any subsurface tool. For static and flowing surface, as we said, pressure and temperature sensors, and especially in the memory mode. The static or flowing pressure and temperature surface can be done in live mode or a memory mode. Live mode will be applied by what? Will be applied by the E-line for receiving the live data during the job. But in the memory mode, we use the Slickline, because all the data are recorded on the memory card and can be retrieved in the surface. So this is by a running hole with a memory gauges. This gauges, and we must differentiate between this gauge and this gauge. This is the memory gauge, which is the gauge to have a pressure and temperature transmitter or pressure and temperature sensors. These sensors are recording our downhole data, but this is called the gauge cutter from gauging or drifting the wheel. Okay, the shifting tool it's attached to our PHA as the main tool. This main tool is attached to our PHA regarding what? Regarding opening and closing the SSD, which is the sliding side door, as we said before, to make a communication between the analyst and the tubing. And also, as we said, beside those routine jobs, there is a non-routine jobs, which is called what? Which is called a fishing job. Okay, when we are using the Slickline, it resembles the second slide we discussed the timeline of the well intervention. So it resembles it, but we will talk here about the Slickline. The Slickline first application during the well life phases, during the completion phase, during the running hole with completion. Why will I use Slickline during running hole completion? To tubing drifting inside the part which installed till that operation. As we know, the completion are connected together by stand or pipe by pipe, and then a running hole. So to ensure that all the tubing pipes inserted into the well are clear, I will drift inside it by the gauge cutter for this completion. I'm also installing plugs during a running hole. Why I will do that? So if you're running with your completion and you need to make a pressure test, the pressure test to ensure the integrity and that the connection of the completion that introduced to the well are good. The integrity and the connection are in a good case, so you can pressure test it by inserting a plug inside this tubing and making the pressure test. Also, after the completion or after running hole with the completion to which is called, if we have here at the bottom of the ear, which is called a surge disc. What is a surge disc? Is a surge disc, it's like a ceramic disc it's installed at the bottom of the tubing to facilitate the pressure testing. Rather than using the plugs. If you run with your tubing to make a pressure testing, if you run with your tubing to make a pressure testing during the completion, you either install a plug to make the pressure testing, or from the first run you will use a ceramic disc. So the ceramic disc here will blank or plug the bottom of the tubing to make the pressure testing during run hole of completion. So after complete the running hole of completion, you need to shear this surge disc, or to break this surge disc to allow the well to be flow to the surface. Okay, and also as we said, installing the plugs to the pressure tests, to make the pressure tests, and also to make the Christmas tree change the nipple up and the nipple down of the Christmas tree. So all this operation of the Slickline during running hole with the completion or after the completion will be maintained by the Slickline. This is operation in the completion phase are applicable through the rig. So it's a rig using a Slickline using the Slickline through the rig. But there is another rigless operation during the production. During the production phase, there is no rig here. So the most common applications of the Slickline will be used as well as well intervention will be used after production phase or during production phase through, and it's called a rigless operation. There is no rig. As we said, temperature, pressure surveys, gas lift valve changes, wireline retrievable subsurface safety valves replacement, and so on. To choose only one application for due to our limited time, so we will choose the mechanical plug. How we install this mechanical plug inside the tube? Firstly, what is the plug here? The plug is the plug consists of 4 main parts: the lock mandrel, the backing, the equalizing sub, and the plug itself. So, to remember, if I want to set any subsurface device inside the tubing using the Slickline in the nipple, to be correct information in the nipple, I wanted to set it in the nipple. So I will use this configuration: the lock mandrel, backing element, and the attached tool down it. If I want to set a plug, I will attach a plug. If I want to set a subsurface safety valve, I will attach the subsurface safety valve, and so on. So this lock mandrel, which is have a setting element or a keys. These keys are engaging inside the internal profile of the tubing in the nipple. As we see here, this is in the pink color is the nipple. Okay, so it's a part of the tubing, a tubing accessory. The nipple is a tubing accessory, so it's a part of the tubing. This part of the tubing have this internal profile here, as we see. This is this internal profile here. This internal profile, whatever, X profile, P profile, XN, F, R, whatever the profile. This profile, it will make a recess for this keys to engage with. As we see here, this locking mandrel will go down as this setting element or the keys will engage inside this internal profile of the landing nipple. So this is the landing nipple, which has the internal profile, and this is our pH or subsurface tool configured from the lock mandrel and the backing, and down it is the plug itself. So by engaging this lock mandrel to the nipple, I will isolate my tubing. Why can we do this by plugging? Why I plug my tubings? Because as we said, for the in the completion phases, I want to pressure testing my tubing, and also to set a production bucker, the hydraulic production bucker, the production bucker, and the type of hydraulically set. It is set by raising the pressure against it. So how I will raise the pressure inside the tubing? By entering this mechanical plug inside the nipple, and the nipple will be down the bucker and raising the pressure to set the bucker, and also used for zonal isolation. If I have a zone underneath the zone I want to isolate and to will I want to isolate. I want to produce from another production zone. So this plug is used for zonal isolation. Also for changing the Christmas tree. How I can change my Christmas tree, nipple down and nipple up the Christmas tree, and there is no any barrier inside the well. So this is mechanical plug will be a barrier, and plugging my inside of the tubing to allow me changing the Christmas tree. To have a look on the real configuration of the plug, this is a real schematic or photo of the plug. As we said, it consists of 2 main parts: the lock mandrel itself and the plug attached to it. The component of the lock mandrel, as we see, the fishing neck here, which the running tool or pulling tool attached to it to set or retrieve the plug. And this is the lock mandrel, which has the locking keys or dogs. Locking keys or dogs are set inside where? Inside the nipple. And this is the backing element to isolate any pressure from the downhole to isolate the well. And this is the equalizing zub. The equalizing zub is attached down the lock mandrel to equalize the pressure above and down the plug, because when you are retrieving the plug, you don't know how much pressure under the plug. So you must firstly open in an internal sleeve here to open the ports. These ports are covered by internal sleeve by means of prong. This internal sleeve will be shifted down, and this tiny holes will make the pressure equalized from the down of the plug and to the up of the plug. By the way, all this lock mandrel has an ID. It's a hollow from inside. Have ID, and this the bottom plug, which is a solid plug having no ID, but it's a rigid or a solid plug. How is this lock mandrel attached to the plug are set into the nipple? Firstly, this is the nipple. This nipple has internal profile, as we said before. This is internal profile of the landing nipple. This is the internal profile. This is cut through inside the thickness of the tubing to make a recess. This recess will receive what? Will receive this keys. So the matching between the type of the keys and the configuration and the angle of the keys will be matched with this profile nipple. So when these keys are attached to the landing nipple, they are engaged together and set in place. And there is in the nipple itself, there is a polished pore area. The polished pore area accommodating what? Will accommodate the backing. So when the backing inserted in the inside of the polished pore area, it will isolate the well, and the remaining of the plug will be here. There is common types of nipples has a no-go profile or be selective. There are main two categories of the nipples. Can be a no-go nipple or can be a selective nipple, and this will be discussed later in the course, inshallah. But till now, we have this plug will be fitted here inside the nipple, as we will see now. This plug, the keys inserted here, and the plug will be down, as we see that. So I now plugging my tubing. Any fluid from the bottom will not can go up to the surface. So plugging, as we said, for the zonal isolation, for the pressure testing, for another purposes of plugging the inside of the tube. And by the way, this is lock mandrel until here. This is the lock mandrel until this here can be connected to any other tools such as plugs, wireline retrievable subsurface safety valve, a separation tool, a downhole memory gauge, whatever I will connect to the lock mandrel. The lock mandrel is the setting element, is the setting element of any subsurface tool, as we said, inside the nipple. To summary what we have said, to answer the main title of our webinar, why we are regarding the slickline as a key to well intervention, because it's like a key. The key allowing me to enter the house, so the slickline allowing me to enter the well. as before any operation, coil tubing, slickline itself, E-line, before any well intervention technique, you have to make a run or a drift run by the slickline. So it will facilitate it will give you the well poor accessibility. Because if you go directly with E-line or the coil tubing or whatever, and you may face an obstruction. This obstruction may make a stuck downhole, and this stuck will lead to a fishing operation and so on. So you need to pave the road or to ensure the well accessibility by gauge cutter, firstly the drift run by a gauge cutter to tag bottom, and also to tag the nipple accessories and the tubing accessories to ensure that the way is clear for any upcoming well interventions. And also, as we said, to prepare the road or the inside of the tubing. There is some subsurface safety valves are wireline retrievable. This wireline retrievable, I can't go through it because it's have a restricted ID. So you must remove the wireline retrievable subsurface safety valve firstly. You must remove the wireline retrievable subsurface safety valve firstly before going downhole by any well intervention application. So also the slickline will do this. The data collection, recording pressure and temperature and so on for any upcoming application like water shutoff or reperforating and so on. So you need to collect those data by using the slickline. And as we said, shifting the SSD for well unloading after completion, well unloading, or for zonal communication to produce from the zone and to isolate another zone. You will isolate another zone by the zonal isolation, as we said, by setting a plug. Okay. Till now, we have discussed the overview of the slickline and picking some applications and give an insight for the mechanical plug, the loop mandrel, and how to set it inside the plug. So for more information about the slickline, all the interaction, the tools, the shear bends, and so on will be discussed, inshallah, on the 5-day course. The first day will give more insight in the well intervention techniques and the well completion accessories and the types of it. In the day 2, inshallah, we will talk about the rig up of the slickline and the pressure tests, and also will be illustrated by videos and animations. And to make what is the pressure test matrix for the PCE and the PHA proper selection, the common tools and application. On the day 3, we will talk about the big category of running and pulling tools, how we run the loop mandrel, how we retrieve it, what is the role of the shear bends, the different types in details about different manufacturers and so on. The loop mandrel and the plug types and setting mechanisms of it, the type of nipples, and in the day 4, inshallah, we'll discuss the different operation and types of the subsurface safety valve, what is the storm choke, how we troubleshooting the subsurface safety valve, how we make exercising and lookout, and so on. And also we'll discuss, inshallah, the gas lift operation, the gas lift retrieving and setting, the different types of the gas lift, and the 5th day, inshallah, we'll discuss the fishing operation and the slickline calculations and the required calculation for designing the operation of the slickline. Till that, I'm very grateful for you to attend this webinar. If you have any questions, I'm all the ears, and don't hesitate to contact through any platform. Thanks a lot.
Thank you, Engineer Mahmoud, for this fruitful session. It was really great, and I really enjoyed it. We will have like 2 minutes break to fill the feedback form, and then we will be able to receive the attendees' question through the chat.
Sorry, we can make 5 minutes for break. 5 minutes.
Okay, 5 minutes break, and then to fill the feedback form, and then the attendees will write the questions in the chat. See you in 5 minutes to answer your questions. Please type your questions in the chat so that Engineer Mahmoud, when he back, he can answer it. Okay, so I think there are no questions. Please, can we get the slides of this course? Or this webinar, you mean? Yes, I'll ask Engineer Mahmoud to share them with us. And once he shared it, it will be on the webinar page on our website. Okay, so I think we have no questions. This is a quick reminder that there will be a full Slickline operations course that will be conducted next Saturday, presented by the same instructor, Engineer Mahmoud Tariq. If you want to enroll to this course, you can simply contact us through any of our social media channels, or just enroll directly through the website that I've just shared the link on the chat. So you can basically enroll directly through website, or just contact us and we will facilitate everything for you. Thanks for listening, and see you soon, inshallah, in our next webinars. About the certificate, it will be automatically generated tomorrow if you joined through the website. So make sure that you enrolled in this webinar through our website, and it will be generated automatically on the same page. Thanks for attending, and see you soon, inshallah, in our next webinars. And thank you again, Engineer Mahmoud, for this fruitful session.
Thanks.